In the previous lesson, we have seen that if three sides of two triangles are equal, then those two triangles are congruent. Now let's look at a case where we know that the three angles of the two triangles are equal. Will that be enough information for us to determine if those two triangles are congruent? As you see in the slide, there are two triangles ABC and DEF, and their angles are equal. Angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. But if you observe, their sides are of different lengths. So these two triangles will not overlap each other if I place them one over the other. So knowing that three angles of a triangle are equal is not enough to determine if those two triangles are congruent. Now let's look at another possible scenario. What if you are given two sides are said to be equal and one angle is also equal? Let's first draw a triangle ABC. With center B and radius equal to AB, draw an arc similar to the white arc that you see over here. Now let's take a point on the arc and connect it with B. Here I have taken the point D and connected it with B, and I also connected D with C. So now if you observe, we have two triangles ABC and DBC. In these two triangles, we have BC, which is the common side, so it will be equal, and AB and BD are also equal because they are the radius of that arc. However, AC is not equal to DC. DC is greater than AC, and if you observe, these two triangles are placed over one another, and ABC is not exactly overlapping DBC, even though the two sides and the angle C in both these triangles is the same. So knowing two sides and one angle is not enough to determine if two triangles are congruent. Now let's look at another scenario. Even here, two sides and an angle are equal. However, the angle that is equal is the included angle of those two sides. So as you see, AB and BC are equal to DE and EF respectively, and angle B is equal to angle E. Angle B is the included angle of AB and BC, and similarly angle E is the included angle of DE and EF. If this is the case, then there can be only one unique triangle that can be drawn. As you see over here, AC will be equal to DF because there is no other possible scenario where I can draw a triangle which looks different and still have sides and the included angle which are equal. This is actually called SAS axiom. SAS is side angle side. So what the axiom states is two triangles are congruent if two sides and the included angle of one triangle is equal to the two sides and the included angle of the other triangle. This is a very important axiom that you have to remember, and we will use it heavily in future theorems and problems. And as you recall from the geometry, an axiom is something that is assumed to be true and you don't really have a proof for it.